we have all gathered here for a case study discussion on effective battery management system in electrical vehicles. So we all know that most of the electrical vehicles rely on lithium ion batteries. So why they use this is they mainly focus on safety and its performance. Even though they are using these kind of batteries, due to excess heat, the cell gets degraded and the thermal runaway occurs. And also due to excessive cold, the system gets degraded due to its low reaction. The effective power delivery is also getting 5 to 10 minutes. You can discuss among yourself and give me a better solution for efficient battery management system in electrical. So hope you have completed your discussion. Can start providing the solution now.
Hello. First, let us focus on the problems, and we'll go for the next solutions. Okay. We all know that the batteries are best at their work until the temperature between 20 and 40. If it is too hot or too cold, the battery life and the safety and the working will be affected. To reduce these problems, we are using NTC thermistors. The thermistors are small in size and lower in cost and more effective. So, in 24 number of key spots, we spotted the thermistor to detect the temperature and the cooling system. The thermistor will detect the cooling temperature and the heating temperature and sends to the systems. Okay. So, but nowadays the roads facing in rough roads, they are facing too many problems in working days. So, for like car temperature detection and low temperature fall detection, too many problems occur. So, let us discuss about the solution for these problems.
So, let me introduce about thermistor first. The word thermistor comes from temperature plus the resistance. Its main function acts like similar to the resistor. What is that means? When the temperature increases or decreases, it just resists the temperature. So this thermistor is composed, it consists of two types. One is NTC, that's the negative temperature coefficient. Another one is the PTC, positive temperature coefficient, where the NTC performs when the temperature of a particular system increases. The resistance will be decreases. These NTC thermistors are used in the EV vehicle management system, battery management system, where the 24 type of thermistors are used in this battery management. It will play a very major role in this system because when the temperature of the battery increases, for example, 1000 degrees Celsius something increases, the resistance will be decreased. This temperature increase data will be sent using the thermistor, and the thermistor, NTC thermistor particularly, acts upon it. So, usage of this NTC thermistors in the battery management system will be very efficient as it is very sensitive to the temperature and it is cost less also.
By coming to the hardware part, you need to change some kind of component which we are majorly using. We should replace it with a standard component such as mainly we are using this thermistor. So we should go with the standard thermistor, that is the NCP thermistor, which helps to increase the humidity and the stability of the roads while using in the EV vehicles. Based on the positive thermistor, negative thermistor, it can change the value based on the temperature of the road and using while using in the EV vehicles. And it helps to this thermistor is will play a major role in helping in stabilizing the temperature and normalizing the temperature. It helps to stable the humidity in our environment. While the vehicle is heavily when the vehicle is in a high temperature, it stabilizes the condition and normal temperature. So by changing the standard components, we can stabilize the heats and the temperatures.
On the electrical side, we can reduce noise and improve signal integrity by using shielded sensor wires and twisted pair cables for longer wiring. And we can also use gold-plated contacts to prevent oxidation. Thus, this will give you a clear reading. On top of that, we can also use software filtering, maybe moving average or median filters to get a clear reading without hiding the rise in temperature spikes. From the redundancy logic, it compares readings from multiple transmitters so that one bad transmitter wouldn't cause a false detection.
And maintenance part. In this, um, we have to display the sensor in three different temperature for cold, average, and high temperature. For example, at 0 degrees Celsius and 25 degrees Celsius and 50 degrees Celsius. Before we implement in the BMS, when testing this sensor, it should give accurate value without testing the values. And next, after testing the sensors, it should work finely. And if it wants to work finely, we should implement better hardwares and proper wirings to ensure it works finely.
So thus, as per the disclaimer, with the help of thermistors, we can go for efficient battery management system in electric vehicles. Thank you all.